So today we'll continue on from Tuesday, which we have talked about uh, the, the the basic of the computer, right? Because so far throughout all the other courses, and I guess including your life as a user of a computer, right? When you use your phone, how many people listen to the or watch the Apple iPhone event on Tuesday? I guess Tuesday late night, Wednesday morning, right? So you see that there's a lot of new things coming out, right? And they'll come up with like new chips, better processor, better camera, better system on chip, right? So whenever new phone comes out, whenever new computer comes out, they actually like another upgrade into your computer, right? So we talk about what exactly is a computer and why and how do they process your information. Because essentially, when you look back, right, when you look back, it's like sit back from watching those news and like see this thing costs a lot. uh, Besides from this thing costs a lot of money, but these are really really good phones. Uh, at the end of the day, they process your input in order for you to get the output, right? Every single computer will basically process information this way. You type in some input, the processor takes the input, process it with the main memory, and sometimes your input go through the main memory, and it's also go to the output devices. The output devices can be your screen, it can be your audio speaker, right? The input device can be your keyboard, your camera, right? Your network packets coming in through the 5G modem, right? These things are actually elements of parts in your computer. In order for the computer to basically programmable and can process your input based on the program's binary, based on the program's binary. What does it mean? Basically, it means the program that you've written and you set it up on your computer in a way that you can run them, right? So here's what happened internally. Internally, if you think about it, basically you have a user. That's you. That's where you are. That rectangle box is you, right? There are two ways you can use your computer. It's either you use the application program. Again, since the iPhone just came out, right? The new one, I've used that example. What's on your phone? How do you use it? You either use an app, right? You either use an app or use something in the iOS, right? That's how you control your phone so that it becomes useful. The computer works the same way. You either use an app or use the OS, right? Or use the OS. So the operating system will act like a middleman between you or the application to the hardware, right? In that way, the OS will basically allow it acts like a shield from you from actually having to control the hardware manually. You can send the command through the OS, and the OS would say, "Okay, hardware, do this." This would make sure that when you change the hardware, for example, you don't have to change the OS, right? You can still use Windows on multiple machines. You have to install them, obviously. But when you change the chip, when you change the phone, when you change the architecture from the CPU one to CPU number two, they're from the same company but different generation, right? The OS handles everything. The OS handle everything for you, and you still work and interact with the OS the same way, right? When you upgrade a computer, when you upgrade your phone, the iOS will behave the same way you've seen before. When you switch the phone, right? You have the new hardware, but use the same old OS, the iOS. And we talk about Unix, which is one of the primary OS in the world. It's multi-user, multitasking OS. It has different versions from serverless, AX, Linux, and it's typically used in scientific and technical application, cloud infrastructure, and also like some IoT devices, right? This is also used in these days. You can use Ubuntu on your PC and your workstation, fine, right? To be honest, in my office, I use Linux on my own PC, right? Because I find it much more useful when I need to like connect to the server, develop my own code, deploy certain like software like Dockers, or like containers within the Docker and things like that. It's much easier for me to use Unix rather than Windows. And also available in multiple distribution. One of the most common ones are Ubuntu and CentOS and Fedora, and Debian is also a common one, but it's probably not as like common as like say Ubuntu, right? And these distribution might vary in some of the basic command, but they works in a similar way. And also have a difference in how they distribute all the new packages that you can download and install on your distribution, right? Some of them would offer more like advanced, like everything that comes out, I'm gonna make sure it's available. Some of them would be more careful with what's going to release to make sure it works well with the machine, right? And then we talk about the terminal. Terminal is basically an emulator that emulate the video display architecture, right? Basically, you look at this. You have the main memory. Sorry. And let's say these are on the server side, right? You can have your own machine, your own laptop, right? This is in class exercise 1 that you've been all through, right? Essentially, you log into the server using your own computer through your own keyboard. You type in something. The terminal allow you to forward that things you're typing to the server. The server process what you just type, display it out on your output devices. So that's how the terminal works, right? And you can use the terminal to command your own computer. So basically now, without connecting the server, now terminal would emulate the display architecture of your machine. We talk about program versus processes as well. Today, we'll expand into how to manage the processes. Processes are basically when you have a program and you write the program, you compile the program into binary, right? Then when you run the program, those become processes. You can run multiple versions of your same program. It would generate multiple processes. They are active instance of things running on your on your computer. It's an instance of the program, right? Shell, we talk about shell, which is basically a software that take in command, feed it to the OS, right? So here is shell on that connection. Basically, user feed in the command, shell say, hey, OS, these are the command. The OS would basically run it, and so that it interact back to the user. And it allow you to control the OS directly, and each user that connect to the shell each user has its own version of the shell, right? So that multiple users can connect to the OS at the same time. In this case, for example, last Tuesday when we have in class exercise 1, right? What happened is many of you try to log into the computer, the server at the same time, and it's fine, right? What's happening is each one of you will get your own instance of shell, and then you basically run it based on whatever config you have on your local setup, right? So locally, if you have only one machine and you use terminal and shell to operate the OS, right? Basically, you as a human would talk to the terminal by typing. Terminal send the command to shell, shell send the command to the OS. Remotely, this is what happened. If you want to connect to the server, right? The shell is a software on the server. Then you, which is basically operating your own machine, will operate on the terminal on your own local machine, put in the input, and then terminal will forward the input to shell. Terminal will then forward the input to shell, right? And that's kind of wrap the Tuesday lecture. So now let's expand a little bit more on Linux. And the first thing we have to talk about is the file structure, right? This is one thing that every computer have. you can store a file, right? You can store a file. And when you can store a file, you have to have a way to be able to access the file, right? So everything, your program and your data are stored in file. And they are organized into directories. So I hope these are pretty self-explanatory, right? You have a program, you have a data, everything is a file. A program in Windows, right? For example, can be the .exe file. What does .exe file mean in Windows for most cases? What does it infer when you have something .exe? It's a file, right? In many cases, when you double click, it is executable. What does executable mean? You can execute them, right? And the file are organized into directory. For example, if you are on your terminal and you type in ls is a command that lists every file in this directory you are in. You will see that there are multiple files here. These are the file name. These are like basically the last time the file get modified. These are the ownership of the file. And these are the group of the file. These are the size of the file. So you basically get the information related to the file, right? So this is basically how your computer organizes a file, right? And to make sure you can access every single file, your computer would manage them in the tree-like structure, right? How many of you use a Windows machine? So for those of you who use Windows, right? What is the most parent version location of your computer? Where do you start from? I guess. Well, no, what I mean is like if you keep going back all the time, right? So you go to my computer and then you go to like each drive, right? That's how your Microsoft like Windows manage your file, right? Again, it's a tree-like structure. Why do I say tree-like? What is in a tree? The tree has a root and it branches out into multiple branches, right? And each branch can branch out again to the leaf, right? So if you're in a data structure class, you might notice that you learn what is a tree. And then the same structure is being used in how you manage the file, right? Uh, how many people here use Mac? So, but see, you said you use both Windows and Mac. Okay, awesome. You have multiple computer. So if you use a Mac, right, when you open the file explorer, right? So if you open the file explorer, where do you start at? Yeah, my wife just told me that's called Finder. Sorry, I didn't own a Mac. I used to own a Mac and I gave it to my wife. Uh, so when you open Finder, right, where do you start at? Do you ever notice like when you click on Finder, it begins somewhere? Where's that location? For those of you who use a Mac. So recent folder, it can be a recent directory, right? It can be your home directory, for example, right? Yeah, thank you. So the tilde sign, that's an interesting answer because we're gonna cover that. Tilde means your home directory. That's where your user accounts file are stored. When you open Finder, you are starting there. Have you tried to hit like going back, and see where do you end up with? Like keep going back in that structure. Anyone try that? If you have not, you should try it. Just go up one directory, up one directory until you cannot go up anymore. where you're gonna end it up at one place. Anyone want to take a guess? So if you keep going up, right, your home directory is here. If you go up and up and up again, about 2 times, you ended up at the root directory. This is kind of like my computer in Windows, right? Or this computer in a newer version of Windows. This is the root directory that store every single location of file in your computer. That's why we call this a tree-like structure, right? One more thing, the extension doesn't mean anything. What do I mean by that? So if I see .txt, what would it mean? txt, it means that this is a text file. Likely it's a text file. So if you double click on that file, what would happen for both Windows and Mac? It's gonna open a text editor and open the file, right? So what if your friend play around on your machine and change the PDF file and change the .pdf into .text? What will happen? And you accidentally double click on a file. Well, obviously it will open the text editor, and because most text editor can open any file, so you're gonna get random text. The reason why they are random text is because sometimes those are binary data. When it's binary data, it's like you just basically get a bunch of bytes and it would try to convert to the ASCII format or whatever text format the text editor is trying to open, right? So yes, binding fonts. So what if, right? What if I change some file, some image file that has the JPEG format, I change it to PDF. What will happen if I double click on that? It will try, right, to use Adobe PDF to open an image file, and it will say, hey, this is not a PDF format, I cannot open that. Let me ask you one more question. When I change the file extension, do I actually do anything related to the file? The data is going to be the same thing, right? You're not changing the data. So the extension doesn't mean anything. The extension only gives hints to the OS that, hey, I guess this is a file of this type. So if you see .text, I guess this is a text file. If you see .jpg, I guess this is a JPG file. So if you use the machine normally as a normal human being, most of the time the file extension actually mean it's a type of certain, like the file is of this type. But you can change it, right? You can change it. It doesn't change the nature of the file. It just change how the OS might try to open your file. Space in the file name is okay. For example, in Windows, you have my document, right? MY with a space and document. In Linux, you can do that as well, right? But you have to have the escape character. This backslash means that treat whatever comes next literally as a space. It's a part of the file name. It's not two different file. It's not two different file or two different command. Treat that as a part of one single string, right? The same string as you learn from Python. A bunch of character, right? Instead of two string objects separated by this space, it's one string object with the space in the middle. Anything that starts with a dot, a file or a directory that starts with a dot, these are hidden file. These are hidden file. Why do you need that? Sometimes, for example, there are a bunch of configuration related to the OS that ties to your shell. For example, how many of you finished? I think most of you finished in class exercise 1, right? That's a .ssh/config, right? Remember that our .ssh slash config. So this is the file that ties to the SSH command, and you can actually configure them. This is step 2 of in-class exercise 1. So the .ssh is a hidden directory. Most of the time when you use a machine, you don't need to access the file. So by default, this is created into a hidden directory. Because when you want to list the directory, these are not going to show up. There's also another file that if you use Vim, you can configure Vim with .vimrc. This is gonna be a primary configuration of the Vim command. When you open this Vim text editor, it can allow even things like I can have Vim check spelling, right? And if your spelling is wrong, it would highlight the text and things like that, right? And now we talk about the dot. Let's talk about path, right? The way you can access a file, you can do it in 2 ways. You can use an absolute path. When you use an absolute path, what does it mean? It means that whatever path you put in start from the root, right? Whatever path you put in will start from the root. This means that the absolute path starts from slash. Slash is root. This is the root directory. In Mac, if you keep going back up, you are going to end up at just this root directory. Slash var slash lock means that start from root directory, go into the directory called var, then go into the directory called lock, right? So these allow you to keep going, right, into each subdirectory starting from root. So this is called the absolute path. Relative path means that you start from where you are. Let's say you are in slash home slash Rashada, right? In my home directory. And I do .assn slash o1. This basically is the same as slash home slash Rashada slash assn slash o1. These two are, oh, not that one. These two are the same thing. All right. So you can refer to a file or a directory using either the absolute path or the relative path. And notice absolute path starts with a slash because that's the root directory. Relative path starts with a dot. Dot in your path, right? Dot in your path means that start from where you are. Start from your location right now, right? Dot means go back one level. Go back one level. So if you are here, then dot lecture slash o1 means that I'm gonna go to this folder. Because you start from slash home slash Rashada, the first dot go out of the Rashada directory. Then the second dot go out of the home directory. And then you go into the lecture and you go to the O1. All right. And now with this dot and the slash, we can talk about the special path. And thanks to one of you, Rinradi. So thanks for mentioning the tilde sign. So tilde refer to your home directory. This basically means that this is where you will start when you log into the server through a terminal. This is typically where you start when you open Finder. This is like your home directory in Windows. Remember your folder name, that the one with your username in it as the name of that folder. That's your home directory. Dot refer to present working directory. Working directory means that where you are right now. Dot refer to the parent directory. Dot refer to the parent directory. Basically, go up one level. Slash refer to the topmost directory, the root directory. All right. So let's do a quick question and answer. Anyone have any questions? So this is kind of like similar to how you use like Windows and Finder in macOS. When you double click a folder or double click a directory, you go into that directory. Dot dot means that you go back up. Dot means that you are right where you are. Slash means go all the way back to the root directory. Tilde refer to when you go to home directory. If you have questions, feel free to type on the chat. I'm basically reading the chat at the same time. Otherwise, I'm gonna go through how you feed in the command when you want to use Linux, right? And it's easy. Just type in the command name, the arguments. Right? It's as easy as that. For example, for those of you who use Python, how do you run Python code? Can you type in some samples like how do you run Python code? I think you all took Python class before, right? So how do you run it? Yeah, Python file name.py or Python 3 file name.py, right? Python or Python 3, that's the command name. It means that I'm going to use a program called Python to run whatever is coming next, right? So that's your argument. You also can have options. When you have options are things like this. For example, the ls stand for list. Literally, as the name suggests, it lists whatever file and directory are here in the current directory. So ls-l means I'm gonna want more detail. I'm gonna list whatever file with more detail in this current directory. You can also have an argument which is a path. In this case, a path is your home directory. So this would list file and directory in your home directory. And don't worry about this. I'm gonna show you a demo because I have I logged into the SysSkill server on my desktop. So whenever there'll be about 2 demos here. About halfway through the lecture, I'm gonna do the first demo and then I'm gonna do the second demo afterward. All right, to show some of these commands. CD stand for change directory. As the name suggests, you change from one location to another. So you can do CD target. CD dot dot will go up one level. CD slash go to root. CD tilde go to home directory. CD dot slash hello will go to the folder called hello in this directory. You can make new directory using the command mkdir. You can remove an empty directory, by the way. If you use rmdir, that directory that you're about to remove has to be empty. If it's not empty, it's kind of like a safety net to make sure you don't randomly remove a non-empty directory. So you need to guarantee that your directory is empty before you do rmdir. MV stands for move from source to destination. So you can also use it to rename a file by having a move source and then within the same directory, change the file name. It will rename the file. CP stands for copy, copy from source to destination. If you want to copy a file, you can just use this format. If you want to copy a directory, you can add -r. -r will copy recursively. RM, no destination. Sorry about the typo on my slide. No destination, because when you remove something, it's gone out of the existence on your computer. Be careful here, because when you use Linux and through terminal you remove things, it's gone. There's no recycle bin for that, right? So when you remove things this way, it's gone. One of my lab mates back in a PhD years at CMU accidentally do remove his code. I think like a month worth of coding, um, by accident, and there was a long swear word after that. I remember for sure. So please make sure when you do remove, make sure it's the file you want to remove so that you don't remove things by accident, right? But you can do rm source if you remove that file. If you want to remove a directory, you add -r, it would remove that directory with everything inside it. Again, this is a pretty, be careful with this command, all right? because sometimes you might accidentally remove things that you're not intending to do so. Touch is a command that create a file. So when you say touch test.txt, it's going to create an empty file called test.txt where you can use it later. All right, so now we talked about the command things like move and copy. And right now, I just say source and destination. What if you want to move multiple file or copy multiple files and directory? You can use wildcard. Wildcard like star. Have you seen this before? Star? Anyone have seen this before? So whenever you put star in for your as a part of the argument, it means that I'm going to refer to everything. In this context, it means that every file that match the pattern. Every file that match the pattern. I'll have some example in a bit. You can use slash between each directory level. For example, if you want to refer to all the file and directory under the directory full, you can do slash full slash star. This star would match, right? Basically, you find what match this pattern. What match this pattern. Star means everything. So everything in that directory would match. So wildcard can be used to represent any character. Star means 0 or more character. Question mark means one single character. Bracket is a range of character. So, quick exercise. What does this do? All right, anyone want to take a guess what does this do? For sure, it's gonna list something. It will list most file in the directory you are in, but what specific file? What specific file name that will it list? It's everything that starts with an A, right? And it can have some number of letters. How many? Any number, but with the question mark at the end, you need to at least have one character. One character. Because question mark means a single character. So something like a file named AA will be listed, AB will be listed, AC will be listed. But if I have a file named A, this will not get listed. Does this include capital as well? No, it's a strict match. So it has to be lowercase a. It has to be lowercase a. So if you want to match both lowercase a and uppercase a, you can do this. So it's a range between lowercase a and uppercase a. All right. So what if I want to match a file that is a PDF file? What do I do? If I want to find, question mark. Question mark means a single character. So whenever the question mark is in the search pattern, it would map, like it would replace question mark with anything, but it's a single character. It has to strictly be one character. So what if I want to search for every PDF file in my in this directory? What do? I do ls something something. What should I put in here? Star.pdf. Correct. Thank you. -L means I want more information. It would print like the last modified, what's the size of the file, right? This, because move text into input, source, and destination, it would say there'll be an error here because you need the destination, right? What about this? mv public html slash star dot question mark g What would it do? What does this do? So what directory will this get moved and where to? So what's the original directory and what's the target? So it moved anything from public HTML into public HTML image, right? And the pattern that would match is basically any file. Oh yeah, thank you. That ends with dot, right? And then 2 letters, G, like dot .jpg, dot .png, dot .img. Hopefully those are image files, so you can move it to the slash image. All right, any questions before we transition into more commands? So what else can we do? Sometimes you don't know what to do with a command. There are so many options with a command, right? So in this case, you can use a manual. Linux comes with a manual for the command. For example, if you type in man ls, basically man would open up the manual for that command. Man ls would tell you how to use ls. Man find will tell you how to use the command find, which is used to find a file on your computer, right? A command called cat is not, it doesn't mean an animal cat, it means concatenate. I'm gonna string together the content of these files. File 1, file 2, file 3, up to file n, and I will output the result, which is I put these file together into one single output. Find means I'm gonna find a file. I'm gonna find a file. PWD, print working directory. Print working directory. Basically, it would print the path of where you are. It basically print the path of where you are right now. Grep, we will talk about this later when we talk about regular expression, which is next week. Grep allow you to search for a keyword in specific file, in the specified file. This is really useful when you become a full-fledged programmer because sometimes you have to work in a large project and you don't know where do someone declare certain function. You can use grep to find that. It allow you to search for just a specific text across the file that match the pattern. So you can search for every file in this folder where is test1 defined, for example, right? A few more things before we do a demo. Redirection. You can use this greater than sign to redirect an output. Instead of showing this on your screen or your monitor, it will show it in a file. So in this case, it would create a new file called output.txt. And inside output.txt, it would contain the result of the first command, cat a.txt b.txt c.txt. You can use this double greater than sign to redirect the output, but instead of creating a new file, it would append to existing file. Typo here. And you can use the less than sign to redirect file as an input to your command. For example, if you want to have a list of like a bunch of file or directory that are in the text file, you can feed that as an input into the ls command like this, right? So you can use the redirection, sorry, you can use redirection to forward input back and forth. One more thing before I do the demo. Pipe is similar to redirection, but it's a little bit different. Pipe means that instead of forwarding and create a new file, I use the output of the first command as an input into the second command. For example, cat file means I'm going to print whatever content is in that file as an output. But instead of printing on your monitor, it forwards this output to WC, which is word count. So think of this as you basically connect two functions together, like command 1 and command 2. The pipe, which is this vertical bar, will forward the output of command 1 to the input of command 2. Before I go to user and group, I'm going to switch over to a demo. No, I'm going to switch over to a demo. Where is my here? All right. Let me share my desktop screen. Can you see my screen that has, well, it's black now, I think. Okay, can you see my screen that has the terminal open and hopefully not my cat walking around? Okay, so you see I'm basically changing the password for you guys for the other section. You can see the screen, right? All right, awesome. So right now we are, okay, what command should I put in to tell where I am? What command should I put in to tell where exactly I am? pwd, right? And in this case, you see that I'm in a folder called /home/rashada/syskill demo, right? You can also use this to kind of give a hint. Right now, I'm logging in as the user called Rashada on a syskill server, and I'm at home, tilde again is home/syskill demo, right? How do I list everything in this directory? What should I do? ls-la, right? So right now, because I did a demo for the other class, the other section, before I do that demo, let me remove merge.text. How do I do that? Yeah, remove merge.text. So see how I autofill this? Sometimes you hit the tab key on your keyboard, it will autofill, right? If there's only one choice, it would autofill this for you. So if I hit enter, you'll see that merge.text is gone. It's just test.text and text.test. Now I regret naming the folder this way. Can you just give me a directory name that I can create through mkdir? Give me one name. Banana. All right, awesome. We have now the directory called banana. And let me move test.text into banana. How do I see the content of the file? I can use the cat command, right? So I can use cat text.test. It would basically print what's in that command. To double check, I can use Vim. Vim is a text editor, so I can open up this file. It will say, hey, I have 2 cats, right? To exit Vim, you can do :Q. So if I do cat, the file in banana/test.text, it would also print the content of that file. In that case, test.text has a sentence say, I have a cat, right? So in this case, you can use cat to basically print what's in the file. You can also concatenate multiple files. For example, I will first concatenate test.text in banana directory, followed by text.test in the current directory. And here's what I'm gonna get. I'm gonna get the output, which is basically the first file followed by the second file. So I'll see I have a cat and I have 2 cats, right? And let's say I want to forward this to an output. I can do this. And I hit enter. What should be in merge.text? yeah, I have a cat, and in the next line, I have two cats, right? So if you bim merge.text, you see basically this. Now I'm going to show you one more example, which is pipe, right? Pipe. So if I do cat, the command cat, not actual cat, and then merge.text, which would give you those two lines, right? Basically, let's do this first. This would give you these two lines, and then I give this as the input to word count. This is what I'm gonna get. This is basically the same as if you do word count on this file, right? There are two lines, the first two means there are two lines, 8 words, 29 character. 2 lines, 8 words, 29 character. You can also do cat, banana, test.text and text.test, and pipe that into word count. It should be exactly the same, right? Because it's the same, it's going to result in the same output into the word count. Any questions about this? Okay, if there's no more questions for now, I'm going to switch back to my laptop. So let's see, works. Screen. All right. So let me know whenever the slide is up. I think it should be up now. So now the next thing I want to talk about is how to control all the user, right? Because in Linux, you have an option of having multiple people using the computer at the same time. For example, the syscale server, right? You have multiple people using at the same time. And based on lecture 1, that's already some of you to say, hey, I don't want other people to use my computer, right? So in this case, because it's a server, you have to share that. You also need a way to control things, right? Because if you have a server and everyone can do whatever they want, it's going to be chaotic. So you need a way to control all the user. User has different types. You can either be regular user or super user. Super user, think about it as a god on that machine. You can do whatever you want. You can do things that would kill the computer, right? You can install a new program. How many people use Windows and see whenever you install a program, there'll be just ding, and then I want admin access to install a program. Anyone remember that? So basically, the OS Windows is basically asking you that, hey, I need the permission as a super user to install the program, because most of the time you are logging in as a regular user. When you install a program, you need to elevate yourself into a super user. That's what the ding and then yes and no are for. Each user belongs to one or more group. You can be in the admin group, you can be in the sudoer group, and other group, and you can create a new group with any name. You can use the command group, which will tell you what group the user is in. If you are under the sudoer group basically means that you can call a command called sudo. Sudo means that I will elevate myself into super user. I'm gonna elevate my power to be a super user to run this command. It's the same as that being I need an admin access to install this program on Windows. It's the same thing, right? And each file has an owner, has one owner. By default, this is whoever create the file is the owner. But you can change the ownership. For example, you create a file for your friends. And at the end of the day, you want to make sure your friends can use it in any way he or she wants, right? So you can do the command chown, change ownership. It would change the ownership of that file. Each file has a group as well. And the way Linux manage the file is categorized into 3 different types: owner and people that belongs to this group, and then everyone else. And each subset of this have 3 different permission. Owner can have the read permission, the write permission, the execute permission. The group also can have the read permission, write permission, and execute permission. So I'm gonna just say X for the execute. Everyone else also have read and write and execute permission as well, and you need to basically configure this, right? And each set of permission will belong specifically for each types of group. Owner, everyone else, every user in that group, and everyone else on your machine. So that's how you manage who own what file. For example, if you look at this screen, right? First of all, let me ask you this. What does this letter D mean? Anyone want to take a guess? What does D mean here? Thank you. It's a directory. It's a directory. These are the name of that directory. Well, these are all directory, basically. This is the group name, and this is the owner. So if you look at the first directory called U5480002, it means that this belongs to the user called 5480002, right? Then moreover, more than this, you would break this permission into 3 set of data. This is for the owner. This is for the group. And this is for everyone else. If there's a letter R for that group, it means that for that 3 part, either owner, group, and everyone else, if there's a letter R, you can read. If there's a letter W, you can write. If there's a letter X, you can run, execute. You can execute the file. So in this case, let's say I look at this directory, right? So the owner can read, can write, and can execute. People in the group, which means that the group student can read. Everyone else cannot do anything. They cannot do anything because I don't give the permission to do anything. All right. So now let's talk about super user and root. So every machine, when you use Linux or a Unix-based system, there's going to be a special user called root, right? Super user is basically the most privileged user. It's like all powerful being in a computer. It's like God in that computer. You can do whatever, breaking all the permission, write your own rule, do whatever you want. In Linux, there's a user that called root that by default, root has a super user power, right? SU, when you type in SU and hit enter, it means that you're gonna switch from your account to the root account. It will ask for the root password, and once you hit enter and put in the password, you become the root, and you can do whatever on your machine. Most of the time, a better way to do this is you can do sudo. Basically, let's say you want to install a program, right, in Linux. You can do apt-get. Apt-get is a command that you can deal with application like installing or removing something. So you can do apt-get install and then the package name. For example, sudo apt-get install Python will install Python on your machine. By the way, Syskill, we already did that for you, so don't worry. When you use apt-get, similar to Windows machine, when you install something, they would ask, I need super user permission. I need the admin access. In this case, you put in sudo, which means I'm gonna elevate myself to have the power equals to super user. And then I'm gonna run the apt-get command to install this package. Sudo allow you to elevate yourself as a super user to run that command that comes after sudo. Another thing is, don't ever use root casually. Don't just log in as root and use the machine unless you really know what you're trying to do here. And in the past 2 years, I find this thing weird because in Thailand, somehow people give root password like candies when they manage the server, right? So it's amazingly common mistakes that in the tech industry in Thailand, or not tech industry. I think tech industry they're fine, but like when you have to manage someone's server that they're not really familiar with, like the IT industry, sometimes they just give you the root password. I'm like, okay, um, this is bad idea because the root can do everything to your machine, right? A better way is maybe create an account and make sure you're in a sudo group so that you can do sudo and a command, right? And anyone here have been seeing this XKCD comics before or know what is XKCD? Feel free to check them out. It's a comic strip that is really geeky and nerdy. There's always a joke about something, and it come out really frequent. So for example, there's a joke about like pseudo, right? So a guy can say, "Hey, make me a sandwich," and your friend's like, "Why do I have to make you a sandwich?" And then the same guy says, "Pseudo, make me a sandwich," and that guy's like, "Okay, I'll do it." Right? So the sudo command is acting like this. It is exactly how sudo command works. If you're in that world, in that computer, when you type in sudo, you become the god. And to actually change the permission of the file, you can use the command chmod. Chmod will take in the bit mask and the file name. This would change the permission of the file. So first of all, to do this, you must be the owner of the file, right? You must be the owner of the file, or you do sudo chmod. You need to be a super user or the owner of the file. And the bit mask comes in 3 numbers. Each number will be from 0 to 7. Why 0 to 7? It's a combination of 3 things. If you want to assign the read permission, you add 4. If you want to assign the write permission, you add 2. If you want to assign the execute permission, you add 1. So when you see the number 7, it means 4 plus 2 plus 1. It means that you give the read, write, and execute permission. And it comes in 3 groups because the first number is for the owner. The second number is for the group. And the last number is for everyone else. For example, if you do chmod 777 test.txt, it means that I'm going to change the permission of this file so that everyone, including people in the group, including the owner, can read and write and execute. Chmod 744 test.txt, it means that you yourself, the owner, can read, write, and execute. The group can read. Everyone else also can read the file. 742, it means that the owner can read, write, and execute. 4 means that the group can read and everyone else can write. This is kind of odd, so most of the time this doesn't happen because if you give someone write permission, you're supposed to be able to read them. Otherwise, how are you going to write over, right? So, question. I also say that Everything is a file in Linux, right? Every program, even the ls command, is a file in Linux. So it means that when you run your command, there's a program that comes in and handle that. This means that the file is somewhere in your computer, right? Somewhere in your computer. But when you actually want to run something, you have to give them the path, right? To where that program is. So for example, when I type in ls, how can it know that the ls is actually inside slash forward slash bin slash ls? How can you know that it's actually right there, right? So my question is, how does Linux know that whenever I type in ls or whenever I type in pwd, it knows to search that command inside the folder slash bin, right? This is done through a magic variable called a path variable. So here's what it is. Whenever you log in through a machine, through a terminal, you connect to a shell, right? So you use a terminal to connect to a shell. And this shell will have some pre-configured variable tied to whatever you want to use as an environment for that shell. So this pre-configured value becomes the default when you log in. These are known things, and they are called environment variable. Windows has them, Linux has them, Mac OS has them. When you run Python in Windows, this path variable tells you the Python you install is in that folder so that you actually can open it. Otherwise, Windows is like, where can I find the command Python, right? So this is what the path variable is for. The same goes for Python on Linux or Python on Mac OS. The path variable will tell you where is that Python executable install, right? So you can run the Python command. Path is basically would contain multiple directory. Multiple directory will be in there, each separated with colon. The symbol colon would separate each path. ls, for example, is actually in slash bin slash ls, right? That's where the command ls is located. So in this case, to be able to use the ls command without typing in slash bin slash ls every time, right? I need to make sure my path contains slash bin so that it searches this directory to find the ls command. And to check where is the command located, you can do which ls. So in this case, when you type in which ls, it would print slash bin slash ls. And when you install new programs, sometimes it doesn't update the path variable. So the way you do this is you can manually update by using the export command. Whenever you put $sign in front of a name, it means that I'm going to treat that value as a variable. So when I say $sign path, it means that treat this as a variable called path. So if you want to extend, like add things at the end of your path variable, you can do this. Export. Export means that I'm gonna assign whatever comes after the equal sign. I'm gonna assign this into this variable. So in this case, what I'm doing here is I will assign the path variable to contain whatever is already in the old path variable, right? Whatever is already in the old path variable, which is here as I show in the blue, right? Whatever is old already in the path variable. And I'm gonna add one more directory. I put in colon right here. And then the directory I want to add in this case is slash home slash rashada slash bin, right? And here's the example. Let's say the path directory has this value. Let's say right now it contains /user/bin :/bin /user/sbin. Whenever I type in ls, where's the ls command? Anyone remember where's the ls command? Just to make sure people are still here. Where's the ls command? In /bin, thank you, right? So this is actually in /bin/ls, right? So the way it works is Linux, when it sees ls, the first thing it do is it will search the first thing in your path directory in /user/bin. Can you find that in /user/bin? No, it's not in that folder, right? So it won't find it here. It will then go search the next one. Will you find the ls command here? Yeah. So it will find the ls command here, and it would use that program inside /bin for the ls command, right? For the ls command. Now, you might be wondering, I kind of know how path variable works, but how can I know what's the path variable that I have on the shell that I'm using right now, right? This can be done through the echo command. What does echo do in real life? What does it mean? What does echo mean? It's a repeat of whatever sound you just make, right? Yeah. So echo command in Linux just print whatever you put in next. If you say echo hi, it would print, literally it would print hi, right? So you might be wondering, why is that useful? That's the first time back when I was trying to learn how to use Linux and I see echo command, I'm like, what is it used for? What's for, right? And then I learned shell scripting. Oh, okay, now I see, I know what it's for. It's the same as the print command, right? So you can print the value inside the path variable by doing echo $path, right? Echo $path. I'm gonna do a quick demo in a bit. To show how this is done. But before we wrap up and switch over to a demo, I would like to talk a little bit more about like how to manage processes, because aside from having multiple users accessing the file and everything, you also have many of your friends using the server, right? So sometimes, how many of you write code that run into infinite loop before? I do, right? Who else has done that? I think many people have done that, right? By accident, like, yeah, infinite loop. What do you do when you run into infinite loop? Except crying in the corner, it's like, what's going on? You would kill that process, right? Yeah, cry, stop running. So so this is basically process management, because when you run the program, right? When you run the program you've written, it already becomes a process. And because it's stuck in the infinite loop, it's a process that would never finish. Yay. Right? So it's becoming a process that would never finish. So you need a way to manage all the process running on your computer. And as I said again, process is basically a running instance of the program, right? It again, by the way, run under certain environment depending on your environment variable. For example, path variable can be seen from the process. But what else are tied to the process? You're gonna have the process ID. Sometimes we call this PID. You are also having the parent process ID. Parent process ID. You also would have the user and the group number to bring shame into whoever is trying to run process that kill the machine, right? So you know who did that and what group did it from, right? Sometimes if your friend's trying to like run things in the infinite loop and on top of that cause memory leak, basically it means that that process used all the memory in your computer. you want to actually kill that process, right? Because it's a buggy program in most cases. Uh, if you love memory, you're gonna love C. And what are we gonna learn next in the C part of the program? Because there's going to be a lot of like dealing with memory. Um. That's a great question. That's a question. Is there a limit on how much memory on a server you can access, right? The answer is depending on the configuration. Anyone here seen this thing called swap before? Anyone here seen this like swap at all? So one thing you know, right? When you buy a computer, you have certain amount of memory. How much memory do you have in your laptop? Let me ask you this. For your laptop, can you type in the amount of like how many gigabytes of memory do you have? Let's say 16, right? So let's say you have 16 gigabytes. Ever wonder what if you use more than 16? What happened? What if you use more than 16? You're gonna start doing the paging. Paging is a process that instead of using the like storing your data in the main memory that you buy, those 16 gigabytes, because you ran out of that, you are going to page and use an area from your hard disk, hard disk. This is called a swap space. This is actually in your hard disk. And you swap the data. The data would be swapped in a granularity of about 4 kilobytes. Sorry, I slapped my hand too fast. I'm getting excited that with that question because it's a great question. It's typically it's 4 kilobytes per one kind of one transaction. We call that unit one page. That's why we call paging. We swap that data into the hard disk, right? Anyone want to take a guess of what's your speed of getting to your data in DRAM in that 16 gigabyte memory versus going to your hard disk? Uh, I think that's a bandwidth. I think you might be talking about bandwidth, and I think these days actually higher than that. But if you think about it this way, right? When you access a file on your hard disk, it's about at least the round trip cost will be like in the millisecond range. If you have a really fancy hard disk, it will be in something like a high, like hundreds of microsecond range. Your memory access is in nanosecond range. So you're talking about at least 1,000 times slower. 1,000 times slower. So to go back to your question, is there a limit of how much memory can I allocate? You can use the swap space, right? You can keep allocating more memory. Yeah, I want more, I want more, I want more. It will go to your hard disk, right? So what happens when you start to run out of memory? What will you notice to your computer? What will start to happen? It will be slower, right? It will be really slow. It will be really slow. Sometimes things crash. Sometimes it seems like it stopped working. Sometimes it's actually not stop working, but it's because everything takes so much more time. Going to get your data between when you process information, instead of 100 nanosecond, you spend 1 millisecond. That's a lot of overhead. Right? Things get 1,000 times slower. That's why you feel like your computer is really slow. Uh, yeah, sometimes it would actually when the OS detect this and you know that the swap, even the swap space, so the swap space has also the limit on the size as well. So if you run out of that, it means it means it's really bad, right? Paging is already bad. If you run out of swap, this is really bad. right? So most of the time you would crash the program because I cannot allocate for more memory, right? I cannot have my memory, so I can't run. Anyway, so hopefully, is it more clear on that question? And I say, is there a limit on how much memory you can have on the server? So yeah, so you can. Thank you. So basically, you can kind of adjust the limit, and it doesn't mean it's gonna go faster because you have to go to your hard disk rather than going to your main memory, and it make everything so slow, right? Again, come back to this slides. So each process would also have priority ties to that. It can have low priority, high priority, and these basically allow the OS, Windows and Linux and your Mac OS to figure out which one to prioritize, which one to run more, which one to make sure they are fast, right? And again, come back to our original question. You run into infinite loop. How do you queue the process, right? Process management. There's a top command that would gather real-time data about running processes. Think of this as your task manager on Windows. How many people use it before? Control, Alternate, Delete, and open Task Manager. We all use that, right? So if you use Windows, we all use that. I think there's also another version on Mac, which I actually forgot what it's called. But on Mac, you can open Terminal and hit run top as well. Type in TOP and hit enter. It will show up. These are the process that I'm running. PS command, instead of a more interactive interface, PS would just list out the running process. Kill? What do you do? Okay, if it's like kill something, what would happen to that something? All right, things go dark really quickly. But when I say kill a process, that process will die, right? I'm gonna get rid of that process, right? It will be removed from running, actually. It will be removed from running. It will remove, it terminate the process, free up whatever process is occupying in the RAM. The OS has also another way to kind of keep track of the where things get allocated. So when you kill that process, you free up the memory. It's kind of like when you open Task Manager and you notice something used too much memory and you end that process, right? How many of you done that before? Open Task Manager and end task. We all did that as well, right? It's like a simple way to make sure a computer can run again. It's the same thing here, and you're gonna get the memory back, right? Jobs will list the command, but not in the like basically we will list anything that you're running in the background. Oh, always this if your computer use too much memory for Dota, I think something is wrong because somehow I can still run on my old desktop and fine. I still play them. Um, so yeah, I think that that doesn't use so much memory. Anyway, the command job would list out the current jobs that run in the background. The command fg would move a background process into foreground. What do I mean by foreground process? Is when you type in the command and hit enter and you're waiting for the output of that command. That process becomes the foreground, right? Background is mean when you hit Control C, you pause the current foreground process and move that to the background. So here are some example of how you can use PS, right? If you want to figure out who has been using my machine, PSAUX. A would show process for all the users. U will display process owner and the username to shame, no, not to shame them, but like to figure out what's happening on your computer. X will show process not attached to a terminal. So these are some of the process that you can see when you run PSAUX, right? You will see, for example, the process ID, how much CPU usage, how much memory usage, what's the command, where does it get run from, where did you start this process, and things like that. right? So if you want to queue a process, you type in queue followed by the process ID. This will send a single SIG queue. SIG queue means it's a signal to tell the computer to queue that process. The OS, when it receives the command, it will have another function to handle killing that process and make sure you free up the memory and free up everything. You terminate the process properly. You can use this to terminate things like infinite loop. Anyone heard about the word zombie processes? Anyone heard about the word zombie processes? If no, basically these are processes that doesn't terminate properly. It kind of die. It doesn't die properly, so it becomes a zombie, right? So the kill command will make sure that thing is dead, right? Exactly, right? For example, if you have a process that process n that trigger process m, right? So n is the parent of m, and say m terminate. This thing terminate, but it doesn't terminate properly. It caused M to like running, and it doesn't know its purpose anymore because I don't even know what I'm gonna return to. That thing becomes a zombie process, so you can kill it, right? What else? You can use the command wget to download the file from the internet. Zip and unzip, self-explanatory, zip and unzip, compress and decompress. Tar would group file together into one single archive. You can also add an option to compress and decompress as well. Curl, you see this in assignment 1, is a HTTP client that you can play around. Head will display the first n lines. Tail will display the last n lines. The up and down arrow would cycle through your history of command in case you don't want to type. The tab you seen this earlier on my demo, it would autocomplete the folder name. Control C would stop the current program. Control R would search the command history. Control L would clear the screen, right? And sometimes you want to, let's say you have a binary file called ls, right? And you want to make sure you run your own version of ls. In that case, when you have multiple names that conflict with the command name, you then need to provide the path. You need to provide the path. For example, in this case, just say ./ls. And for executable, right, when you have the execute flag for the permission, in shell, you can run things like a valid program. You can run a program on your computer for sure. You can run a bash script, right? To run these things, you need to make sure the execute flag is on. The execute flag is on. You can do chmod, right? You can do +x. +x means that we'll take the old permission but add the execute flag. And that's it for the class today. I'm gonna do another quick demo. So let me share the screen over here. Let me know whenever the presentation come up so I can keep showing something. Is it up? Can you see the screen? Okay, I think it's up. All right, so ls again. Nope, I need to go back to this. So if I do ls-la, right? Let's say I want to change the permission for the merge.txt, right? What I can do is I can put in the what if I do this? Chmod 700 merge.txt and I hit enter. You will then see that I changed the permission from read write for you owner and group and read for everyone else because it's 700. 7 means read write and execute for owner. The second 0 right here, the first 0 means for the group, so there's no permission for the group, you can't do anything. Also, no permission on the everyone else, so you cannot do anything. So that's how Chmod works. Another thing you can do, top, you see this? Yes, you can prevent yourself from reading your own file. You can do odd things, right? To be honest, if you own the file, you can do odd things with them. So this is what I just did. I just ran top, and you can see, hey, swap, right? Megabyte that are in the swap space, 0. This is a good thing. This is a good thing. Megabyte that are being used in the main memory, what are running? PID, right? Process ID of that user. Someone's running a container on a machine. So someone is running a container on a machine that use about 2% CPU. And is this one of you guys here? 6280164. Because I figured it might be from Ajahn Kanat's like summer fun class that talks about like Node.js and like Docker and everything. So feel free to experiment on a server as long as it doesn't like make your friends suffer through like using all the CPUs and using all the memory. Feel free to use them. It's fine. But you can see what's running. R mean is running. S means suspend. S mean is not running. To exit, you can do Control C. Control C will exit this. If I do PS AUX again, it would print a bunch of things that are being run right now by multiple users, and there'll be a bunch of information tied to that as well, right? Because I don't have anything to kill, I'm not gonna kill anything. All right, but that's basically it. So that's kind of wrap the lecture. Let me kind of finishing up with the in-class exercise, right? So before we transition into shell scripting, next Tuesday I'll start to talk about how to be lazy, right? So you can write a series of command in the file to automate things. So that'd be next week. Oh, that's a question. So if you cause trouble on the server, would you get punished? Nope. I have sudos, I can do whatever, as long as you don't copy your friend's code or like delete your friend's at lab submission, right? Then you're fine. Experiment with it, right? Learn from it. One thing I love to tell students is like college is where you experiment with things. Like, that's where you experiment with things. Um, so in class exercise 2 is already on the canvas. Feel free to check it out and follow them. And I'll stop the recording right now.